All right. Good afternoon. I was just looking at Bessie over here and I've noticed that she's got violated by all kinds of stickers and mostly concerned about the Hack for Kids stickers. Like, what's the most inappropriate stickers that you used to violate? Poor Bessie. All right, so I'll just go ahead and get started. I'm going to talk a little bit about hacking. I heard you guys are interested in that kind of stuff. So what I'm going to talk about today is some attacks you can do with little pocket-sized devices, like something like this small. It fits in a small Altoids Mint case. A couple years back, I wrote a little book called Hacking and Penetration Testing with Low-Powered Devices, which is an obnoxious title, but the publisher made me do it. Okay. So I've talked about some of these things before. How you can use something like a BeagleBone and create a Dropbox or remote hacking drone and some other things like that. And today I wanted to focus on certain kinds of attacks, like USB-based attacks, that you could do with something like this teeny tiny guy that is called a pocket bone. Right? So why should you care about that? When you have these little devices, you have something that's small and flexible. You can battery power these things for days. You can do all kinds of fun things on pen tests. And today I'm going to talk about what you can do with some brief physical access with some of these things. So who am I if you don't know me? I'm a professor at Bloomsburg University of Pennsylvania. University makes me say that, even though it's the only Bloomsburg University out there. And I teach in our digital forensics program. We have one of only 6 NSA DHS centers of academic excellence teaching digital forensics in the world, so we're kind of proud about that. I've written a few books, written 4 books in the last 3 years. So the Hacking and Penetration Testing with Low-Powered Devices book, and a book on Linux forensics, Windows forensics, and this GrrCON released a book on USB forensics. So I've been programming for a while, since I was about 8. And my daughter was a late bloomer. She only learned Python when she was 9. But she kind of one-upped me because she's 12 now, and she does electronics. She did that starting when she was 10, so a little earlier than that for me. Also been known to fly, build planes, skydive, teach people how to fly, and do other aviation kind of stuff. Course author for Pentester Academy and Pluralsight being over there on the other side of the vendor area today, and some other folks as well. All right. So, what do I want to talk about today? I'm going to just give you a really quick overview of the system and what are the Beagles about, and my special version of Linux that I like to run. It's called the Deck Linux. And then we're going to talk about how you can export a USB attached drive on one of these devices as read-only. So basically you can make a nice cheap write blocker. How could you write enable that device? How could you impersonate a mass storage device? This is something I talked about back at DEF CON 20. And also how you can make a scriptable USB HID keyboard. Right. Now, first of all, a couple of disclaimers. I recently discovered, like I was reviewing this stuff during the last talk, that my slide deck got corrupted. So in the last half hour, I literally recreated this whole deck. So I apologize if there are some little glitches here and there. But thankfully, I have some demo videos, which I think are okay. So the other disclaimer is that I submitted this talk using this little guy here, and this is something called a pocket bone. And I felt really special, right? So the folks at the BeagleBoard organization, if you're not familiar with them, they're into open source hardware. And so they release their specs for all of their different devices, so anybody who wants to can build them. And they released the specs for this pocket bone some months back. And they did a couple of limited runs, and they sent me one of these, and I thought, wow, I feel really special and loved. because I have one of these, and not too many other people have them because, small runs, they're really expensive to make. And 2 weeks ago, they released the Pocket Beagle, which is a lot like this, but not exactly, and it's $25, and everyone in the world can buy it at standard places. So I don't feel quite as special. So when I made this talk based on this, but the truth is all the stuff will still work with a Pocket Beagle, not a pocket bone. So those are my disclaimers. So, all right, so a little bit about Deck Linux. So Deck Linux is not really anything special. Sometimes people are like, oh, I got that Kali and that Kali. You can do so many things with Kali you can't do with other Linuxes. And I'm like, no, not really, right? So mine is not really any different. So what is Deck Linux? Deck Linux is basically Ubuntu with a boatload of hacking tools, thousands of hacking tools built into it, and it's optimized to run on the Beagles and similar hardware. Right? So to that base OS, I've had several additions. I've had what I call the mesh deck. The mesh deck allows you to use 802.15.4 radios and Zigbee radios in order to connect a bunch of small devices into a network and just hack the living crap out of people, right? So basically, I can put a dozen of these things in a small bag, take it to an engagement, do a pen test. I can be up to 2 miles away by the hotel pool, kind of managing the operation as my little hacking drones and minions are out there doing stuff. Also have the air deck. You see this flying wing platform. It's called a quad shot. That is running Deck Linux. And I added something called the 4-deck, which has some forensics things. And then today I'm mostly going to talk about the U-deck, which is USB-based attacks. So by the way, all these things in the picture are all running Deck Linux, and they're all hacking items. So I've got the flying wing over here, and I've got this guy here. I'm sure most of you recognize, what is this blue thing? A Dalek, all right? So it's Dalek Desktop Defender. So a couple years back for Christmas, I got one of these. ThinkGeek sells them. I don't know if they still do, but it's a little toy. People walk by your desk, and it has a motion detector, and it starts yelling at them. And it says things like, exterminate, and other, Doctor Who type things, right? Well, mine broke, so I had to fix it. So I'd taken it apart. I'm like, hey, there's tons of empty space inside, and it's a USB-powered toy, right? So if I'm doing a pen test, and there's somebody who likes Doctor Who at the target, which is often the case, they might get a nice present from me. It's like, hey, look, here's a little Dalek toy. And what are you going to do with that if you're a Doctor Who fan? You're going to put that sucker on your desk. You're going to be like, hey, plugging it in, and you can show it all your friends, right? So inside, it's going to be a Beagle and a wireless adapter and an XB radio. So I'm going to be sniffing your wireless, getting on your network, and then transmitting stuff a couple miles away. And guess what? I can be there forever because it's a USB-powered toy. You're going to plug it in your computer. It doesn't show up as a device because it's not, but I'm going to leech power off the toy. So it's one of my favorites. The guitar is a gaming guitar. It's what I call the Hacktar. Inside of it, again, it's got a Beagle, and it's got RFID stuff, Bluetooth, Wi-Fi, and fun stuff like that. And some other little Beagles, and a lunchbox computer. This one was my first lunchbox computer. It's in a Buzz Lightyear lunchbox. Does anyone know why Buzz Lightyear? What's Buzz Lightyear say? To infinity and beyond. That's how far I'm going to hack you with my little lunchbox. It looks so innocent. Oh, my kid forgot his lunch. I'm just bringing it to him, but yeah, maybe not. All right. So those are just a couple of things that you can do with some small electronics. Okay. So let's focus on what I want to talk about today. So today we're going to talk a little bit about USB stuff. So the first thing you should know is if you have a little computer board like a BeagleBone Black or Pocket Bone or Pocket Beagle, and you plug in a USB cable and you attach it to any computer, it's going to come up as a couple of devices. It's going to come up as a storage device for the BeagleBone Black in particular, and it's going to export the drive that's built in. There's 4 gigabytes of built-in storage on that board. It's going to export it to your PC. That way, if you screw it up, you can fix it. Right? That's kind of the idea. It's also going to give you networking. So it's going to set up, networking over USB if you connect it to your PC. And how does that happen? Well, that happens using something called a USB gadget. So a USB gadget is a composite device. That just means that it has multiple devices in it. And this is something that comes with Linux. And the default for most of the versions of Linux that will run on a Beagle, including Ubuntu, is that you will get networking and you're going to get storage. Right? And that's all done with this gadget device. You can do other things with it, but that is typically what they do. So on the Beagle, you're going to see a device that's called G_multi. It's the gadget device. And as I said, it normally exports a few things. It sets up networking so you can talk to your PC. By the way, how many of you are familiar with the BeagleBone Black? All right. So if you're not familiar, one nice thing about it is you buy it, and it comes in a box, and it has everything you need literally in the box, right? Including a cable, right? You don't have to go buy stuff like, I don't know, some other competing boards. I won't mention which ones. You know which one I'm talking about. Where you have to buy a bunch of stuff and download a bunch of stuff. So you just plug it in, and it works. And part of the reason it does that is because it sets up the networking. It even has a web server, and it'll tell you, here's how you use this thing. Right? Now, this default situation conflicts with what I want to do. I want to do some USB stuff, so I'm going to have to get rid of that device, configure it a little bit, and then re-enable the device. So first off, how can I export my device? I want to take an attached USB drive that I've attached to my Beagle, whatever form of Beagle that is, and say, hey, I plugged this whole thing into a PC. I want to be able to see it. Well, it's actually pretty easy. So if you look over here, I've got a very simple shell script. And of course, some of my students will know this. All proper shell scripts begin with shebang, bin bash, or whatever. And first, some systems, you might have a Getty process, a terminal process, running on that networking. So this just says, hey, if it's out there, please kill it. Unload the gadget using modprobe-r, and then set up a couple of variables and unmount the drive. So I'm going to iterate over the dev SD stars devices, and I'm going to store some information and go ahead and just unmount it. Right. Very basic shell script. Once I've done that, then I'm going to strip out like a leading comma because I have this big long list. And I'm going to store that in a drive for later. And then I'm going to send up my vendor ID and product ID, and I'm going to be all 1337. I'm going to use that for my vendor and product ID just for grins. You can pick your favorite one, by the way. Some of you may know this, and some of you may not. I'm using a little trick here in the bash shell. If you want to do math, you can put double parentheses preceded by a $sign in there, and it will do math. And so basically, that's doing the math of saying, oh, that's hex, and please convert that to decimal for me. Okay. All right, so I store off these vendor ID and product IDs in case I need them later, and then I just go ahead and reinstall the device, and I give it some options. So I say it's G and G_multi. Here's a file. Treat it like a CD-ROM. No, thank you. and it's read-only. It's not, it is removable, and I give it the vendor ID and product ID that I set up. And I can pick whatever one I want, right? So what does that look like? So hopefully this video didn't get corrupted with the rest of my presentation. Let's see what it looks like. So here I am, I'm on my connected laptop, and I'm going to have a look at the beagle that's been connected, I think. There we go. Okay. So I've connected it, and here's the default situation. It comes up with a file system called boot, and now I'm going to unload it. Did you notice how it flashed up a little disconnect message for my networking? Because it said, oh, you just disconnected this device, which included a networking device. And so now, I'm back here. And here I can see there's my composite device. And here's my networking device. And it has the address 192.168.7.1. And I can ping it. And I can use SSH to go on to my device. Now, for the purposes of this demo, I just looked at what was mounted, and I ran that little script that I just showed you. And now it's come up with a USB drive that is connected to the Beagle, not to the PC. So now it says, hey, look, there's this drive. Here it is. It got mounted as SDB in my case. And there should be more to this part. Now, one thing I will say, I'm not going to wait till it comes up. I'll just tell you for time reasons. For Linux, Linux is a lot smarter in general than Windows. You can just stop there, but especially when you talk about things like USB. So for Windows, if you say, this is my vendor ID and product ID, and you tell it what the vendor name is and the product name is, it will just stupidly tell you that's what it is, right? So if you look and you say, what is this? It's a SanDisk, whatever, and it'll say that's what it is. But in Linux, what you'll find is that Linux is a lot smarter, and Linux will say, oh, it reported itself as 1337, 1337, but that's not legit. So it doesn't pick up that string that you reported from your device. It says that's BS, and instead, it's going to just give you the raw numbers. Right. Okay, so now you have this device exported. You might want to make it writable. Well, why would you want to do that? Okay, well, this is great if you want to have a USB write blocker, which can be a very useful thing. A couple years back, I did a talk at Black Hat Europe, talked about how you could make a $20 or €20 device that will do this kind of write blocking, but you might want to re-enable the writing. Let's say I have a drive and it's got all my tools on it. I'm going to use it to compromise the machine. Once the machine's been compromised, and after I shut down antivirus and other things that might attack my drive, then I can make it writable so I can exfil some data. Right? So how do I do that? It's actually very simple. So here I have a very small script, and I look and I say, did that file that I saved exist? And remove the device again. And now I'm going to rerun this, and I'm just going to have a slightly different string that I pass to modprobe when I install gmulti that makes it writable. Right? and then boom, it's writable. And again, be careful, you know, DFIU, if you don't know what that stands for, look it up, right? So what does it look like if I make this writable? I'm going to go ahead and fire off this simple little script. So here where it says root at ARM, that's me logged into the Beagle. And if you see it says, you know, Phil at something else, that is my laptop. Right. So back on my laptop, boom, this came up. Notice it temporarily disconnected my networking. And now on my laptop, when I look at what's mounted, I will see that in fact that is mounted, and notice that it says RW as the first option for the mount. All right, so that's fun. You know, I can do some write blocking, I can turn it off. Well, what if I want to do something else? So, you know, I think it was DEF CON 20 or so, I did a little talk on USB impersonation. So what if I want to impersonate an authorized device? So often you will see an organization that says, we're going to get smart, we're going to whitelist stuff. So you can't just mount any old thing on our network, which is a great idea, right? Unfortunately, they do often use things like vendor IDs and product IDs and just whitelist and filter it out, right? This is essentially like MAC filtering for your networking. MAC filtering, does it work well with wired networking? Not too bad, right? What about wireless networking? Wireless networking, MAC filtering is completely useless. And why is that? What do you do every single time you transmit on a wireless network? Here's my Mac, here's my Mac, here's my Mac. Right? So it doesn't work very well. But, so what I did is I originally made this microcontroller-based device that would allow you to impersonate an authorized device. So I have a list of a couple of thousand of the most common vendor ID and product IDs. You could also set it to a known good value if you had that. And I thought, well, it'd be fun to kind of recreate this where you didn't have to do any soldering and you didn't have a microcontroller device that has this limitation that it's limited to USB high speed only. I'm sorry, full speed only, not high speed. So it's 40 times slower than this would be. So the other thing that's kind of cool, if you look into that, like you know, the USB book I just released this summer is the shortest book I've released so far, and it took me the longest to write, in part because of a lot of these things that changed. But you know, it's thousands of lines of C code or a few lines, maybe 100 lines of shell script, and you get better performance. So I think that that's kind of a cool thing. But so here is my impersonator set up. I have a little usage function, and then I have my vendor ID and product ID. I declare those as integers. I also have a delay. How long do you want to wait? And basically what you do is you say, try to mount it, and then wait, and then try another one, and try another one, right? And here I'm parsing those command line arguments. And then I need to unmount the drive. By the way, I will warn you this, if you're doing image searches, be very careful when you use the word mount in an image search. You'll get a lot of things you probably don't want to see and you can't unsee sometimes. All right. So here, to unmount the drive, this looks kind of similar to what we had before. Is there a Getty process? If there is, let's kill it. Let's get rid of the mod probe. Get rid of the G multi with mod probe -R. And, you know, everything's the same here except for the fact that I'm going to select a vendor ID and product ID. Okay. So I'm going to export my drive, and I'm going to go through a file. So I'm going to go through that file, and that's what I'm doing here, where I've got this little line. and then I set my vendor ID and my product ID, and I mount it, I sleep for my delay time, and then I keep going. Right? So this is my little while loop. I'm going to read it in, mount it, and I'm going to keep going until you stop it, or until it gets mounted. It's really very simple. So this is kind of the heart of it. I mean, really, the other stuff was just setup for that, and documentation, stuff that you don't really even need. All right, so what does this look like? When I take the sound off, I think I should type faster. And so here I've done it LSUSB, and I plugged in my device, run LSUSB, and I can see a SanDisk Cruiser. This is me just plugging it right into my laptop. Just say, what is it? And then what I'm going to do is unplug that, plug it into the Beagle, and then plug that arrangement in to this. So this is on the Beagle that I'm running my script. And over here, you can see that it's been mounted successfully. And if I go back to the Beagle, I can see what the vendor ID and product ID was that worked. Right? Now, in the case of this, this demo, I wasn't actively blocking the different vendor ID and product IDs, but I certainly could. So now if I were to rerun that LSUSB, it should come up, and this one says it's a Kingston Technologies flash drive. Right? Okay, so let's do something a little different. Let's make a keyboard and a mouse. Right? This sounds like a little bit more fun. So if I want to do this, I want to create a human interface device. Remember, the default is that you get Ethernet, and you also get the drive, the internal storage, if it's a BeagleBone Black, exported. So I want to have another script that's going to do this, and I'm going to do lsmod, and I'm going to look and see if gmulti is in there. If that module or device driver, if you will, is loaded. If it is, I just remove it. And then I need to create my HID device. Now, the HID device uses something called a config file system. How many of you are familiar with config.fs? Right, like 5 of you, looks like. All right. So it's, in Linux, everything is a file, right? So they have a lot of pseudo file systems that are used to configure things, keep track of things. And a config file system is pretty nice, and it's used to configure many devices, including some USB devices. Okay. So what you can do is there should be a directory called syskernel config, and you can look and say, do I have a config file system? And if I do, I want to unmount it. I have to unmount it so I can change it. And then I can mount it using mount none. I'm not mounting it really anywhere. And it's a config file system type. And then I need to create my device. So first of all, I have to create the actual keyboard device. And so I have a little file that has all the different flags and things that have to get set. And I say, is there a directory out there for this keyboard in the config file system? If there's not, then I'm going to make it. And then I'm going to echo out my vendor ID, product ID, USB version, and also my keyboard is USB 1.1. Right? Then I have to add a configuration to that device. So once again, I'm going to check and say, under my keyboard directory, is there a configs directory? If there's not, I'm going to create one, and I'm going to create one called C.1 for configuration 1. And then I'm going to echo out various things, such as the max power. So the maximum power I'm going to say is 500, which essentially says an amp, right? That's a lot of power for a keyboard, but I'd be suspicious if a keyboard got connected that says, I need an amp of power. But yeah, that's a story for another day. When you talk about defensive things, how can I detect people doing weird stuff like this? That's one of the ways you can detect that they're doing something weird. And then you go ahead and make another directory, hid USB 0, and a little bit more setup. I have to say this is a subclass 1, protocol 1, and report length. The way that the keyboards work is they actually send reports to the computer, and there are different kinds of reports, and I'm going to send an 8-byte report to the computer. Now, a quick aside on this. For a keyboard, some of you might be old enough to remember that keyboards didn't used to be USB. Some of you might be surprised to find this out, right? They used to have PS2 connectors, and even before that, they had keyboard connectors, right? The bigger thing, all right? And then PS2 connectors, what's the problem with those? Same connector for your mouse, right? So you're like, oh, that was the wrong one, and you're like crawling under your desk, and you're trying to plug stuff into the right port. It was kind of a pain in the butt. But so why did we have PS2 mice? Well, when your computer boots, it doesn't have USB running. So you might wonder, how does that even work? How does the computer know how to talk to this keyboard before it's fully booted? And the answer is there's a different protocol. There's like a boot protocol that you can use for a keyboard. And it's just a simplified protocol. It doesn't use these fancy reports and such. So here's a little tip. If you're trying to detect somebody's fake keyboard, they're like a little rubber ducky type device. A lot of those devices that are based on microcontrollers in particular don't have enough power to really be configured as a regular keyboard. So if you have somebody that has something configured in boot mode attached to your running Windows system, yeah, it's probably fake. So I would say that's an easy way to detect this is a bogus keyboard device. Now, guess what? Since I'm not doing that, you can't detect mine that way. But there are other ways you could detect this. Okay, so now what do I need to do? I need a report descriptor. So if you know anything about USB, it's all about descriptors. There's descriptors that describe everything from what's the device like, how much power does it need, what protocols does it support, what kind of device is it, what endpoints does it have. All of these things are used, descriptors are used to describe them. For HID devices, there are also HID descriptors, which describe these reports. Okay. So we create this report descriptor, we create a symlink for the configuration, and we just activate it, right? Which takes longer to say than it does to do. So this is doing all those things. So I copy this binary descriptor file. If you're wondering how do you make one of these files, you can go out to the USB org site, and they actually have a tool where you can generate this, right? You can automatically do this. It's a very common thing people do. Then I create symbolic link on the second line, and then I activate it by echoing out MS-USB, HDRC, 0, auto to the appropriate place, and then boom, it's working, right? If you care what that HID report descriptor looks like, here's what it is. And again, this is easily generated using the tools available online, right? And this is the text version of a binary file that gets sent. Okay, so let's go ahead and see what this looks like. So I'm going to create my HID device and go back to my laptop eventually. Oh, there you go. Do an LS-USB, and notice 1337, 1337, right? Linux is too smart to accept that that is a certain brand device. So if you're targeting Linux people, be a little bit smarter about it, right? You know, give it a real vendor ID. Don't use 1337. I mean, it's probably like a big red flag anyway. So now I have my device connected. I could use LSUSB to drill down on that device. I can say, please give me detail. So I'm asking for verbose stuff on the device 1337, 1337. And sure enough, it says that's a human interface device, and it's a keyboard, and it kind of scrolled by, but I also saw where it said that it has 8-byte reports. All right, so now I need to use it. It's not that great if I don't use it. So how does this work? And this is a standard keyboard report, what it looks like. I mean, there are other reports that you could have, but this is pretty much the standard one. So we have a byte that's a modifier, right? What does that mean? Did I hit Shift, Control, Alt, Window key, Meta key, you know, all those funny special keys. And by the way, there are different modifiers for the ones on the left side and the ones on the right side, right? And then I have the keys, and I have in bytes 2 through 7 up to 6 keys that I can use. Now, all I have to do is send those keystrokes, send this 8-byte report to dev hid g0, right? And that's all I need to do on the Beagle again, all right? And I have to send a key press, and I have to send a key release. So basically, I send a key press, and then I send a nobody's pressing anything to make it stop. Of course, I'm going to use Python for this because, you know, who wants to like do this manually? I don't want to do that manually. So here's a little Python script. I created a list of the key modifiers, and then I have a key code to ASCII table, right? Because for whatever reason, they couldn't make it simple, right? They couldn't make it where ASCII, capital A in ASCII is what? Hex. Let's see who knows their ASCII codes. A, 41. B is 42. I should have asked B, because then, you know, 42 is the answer to life, the universe, and everything. All right. So anyway, that's what this stuff on the right is. It's just a mapping. So the A key is 0, 4. B is 0, 5, etc. I don't know why they did it that way. That's just, and why didn't they start with 1 for A? I don't know. I didn't come up with the system. And I created a little class just to make it easy, and a couple of methods that I added. You know, send a key, where you can give it a key code, and it'll send it. It'll send the key press, send the key release. Then I have send shift key, send a character. So if I want to send a character, it'll convert it from ASCII to a key code. I have send a string. I want to type a whole thing in. And I have some other basic stuff, right? So there's more to that class than just the couple of things I showed you, but that's all you really need. I mean, they're convenience things that I have. So now let's start by attacking Linux. So here's a simple Linux attack. You know, I create my Python object. I get the environment variables. I hit the enter key. I start up nano on a file hacked txt. And then I just 10 times put in a string, you are so hacked. And then I send a key that says, hey, please exit. And it's going to say, do you want to save? And I say, yep, sure. And I said, hit enter again a couple times. And then I'm going to cat out their password file to another file. And then I'm going to clear the screen, right? So it's just very, very basic. Obviously, if I was going to really attack you, I would do something a lot more malicious than this. But this is just kind of a quick demo. So here we go. I'm going to launch my nefarious Linux attack here. All right. And there it goes. Done. All right. So again, if I have brief physical access, I walk up to the computer and bam, plug this in and it's done. Right? And you can see I have this new file and I have got your passwords txt. If I cat out the new file, it just says you're so hacked a few times, and I can cat out the password file, and there you go. Right. So again, I would do something a lot worse to somebody if I was actually attacking them. But that's how I could do a simple Linux attack. Just very simply script it. Well, what about Windows? I mean, come on, let's face it. Is Windows good for much? It's good as an attack target. Right? Although, I got to say this, I'm very thankful for Windows. Why am I thankful for Windows? Teaches you what not to do, but if it weren't for Windows, none of us would have jobs. Right? Think about it. Like, if there wasn't all this vulnerable stuff out there, we wouldn't have the InfoSec industry, we wouldn't all have jobs, and, those of us that aren't in academia making gobs of money, right? So, okay, so here's a very simple Windows attack. Again, I create my HID device. I send it the Windows R key, which will run something. I say, please send it the line notepad. So I'm going to run notepad. And then 50 times, I'm going to put out this string saying you're so hacked. Then I'm going to hit Alt F and then X, which should exit and save. I'll press enter. And then I'm going to send the line hacked.txt. That's the file I would like to save it to, please. And then I send a character that will turn your screen upside down. Right? Some of you have probably done this to people. It's a lot of fun. And then I lock their screen because I'm kind of a nice guy. Well, not really, but sometimes I'm nice. I'm like, hey, you left your computer unlocked. Let me hack you, but lock it when I'm done. All right? So this is kind of what that looks like. Go ahead and run this. So again, I'm back here. Here's my Windows box, and I just launched my attack. It ran Notepad, entered some text, decided to save it, and then it locked the screen. Now, you might be wondering, you're like, you lied, Phil, because you said it was going to flip the screen upside down. To make this demo easy to record, I actually ran this in a virtual machine. Because I ran it in a virtual machine, it doesn't flip the screen upside down. But just trust me that if you run it on an actual box, it will flip the screen upside down for you. Right? And you can go back in and you can see that it created a couple of files and did some stuff. So, all right. So again, I apologize that I had some technical issues where, I literally recreated this stuff, and I discovered it a half hour before my talk today that I had a little corruption problem. You should know, though, that I did back my stuff up on. I backed up my stuff online, and I don't have good internet access right now to grab it. But so apologize if there were a couple little glitches in there. But if anyone has any questions, now's the time. No questions. Is this on GitHub? Yes, it is. Right. So if you go to GitHub, why don't I real-time edit my presentation that I just created? So if you go to GitHub, P. Postra, you will see I have a couple of things. Oh, it would help if I put this back up. I'm looking at it, and it looks great on my screen. And you're like, hey, there's nothing there. But yeah, if you look under my GitHub, you'll see a couple of projects, and one of them is called the UDEC, and that has all this USB stuff. So you should be able to get it there. Other questions? Yes. No, it is not hard to set multiple modifier keys at the same time. No, it's a bit vector. So no, you can set, like if you want to send Control-Alt-Delete, for example, you can easily do that. So good question, though. Other questions? I'm not good at seeing people, so if you have your hand up, raise it higher. All right, well, thanks a lot, and enjoy the rest of your afternoon. So thanks, guys.